Sample problem D, precipitation calculations. Will a precipitate form if 20.0 milliliters of 0.010 molar barium chloride is mixed with 20.0 milliliters of 0.0050 molar sodium sulfate? First, we need to analyze the problem. What do we have? What do we need to find? Well, we're given the concentration and amounts of the reactants. Great, a perfect place to start. What do we need to find? Well, we have to determine if a precipitate will form. What's our plan? Our plan gets a little bit involved, so stick with me, but I assure you it's not going to be difficult, but we need to take this step by step by step. Okay, our plan. First, we're going to need to find the products. What happens when these things react? What about the dissolution? What happens when we have those ions? We need to write down that equation for dissolution. We also need to determine the solubility. Once we understand the solubility, then we can determine whether or not a precipitate will form. Okay, let's get into the action. Let's take a look at what's happening in this problem. We have barium chloride placed in solution with sodium sulfate. What can happen is that the barium can then associate with the sulfate and form barium sulfate. Also, the sodium can associate with chlorine and form NaCl, table salt. So these are the two possible products that we have. Now, table salt, you know, dissolves, so we're not even going to worry about that. We're going to focus on the barium sulfate. To determine whether or not barium sulfate forms a precipitate, we need to know something about its solubility product constant. And we're going to be looking up the KSP for barium sulfate on this chart right here. Okay, so this is the chart that we're going to use. And from this chart, we'll find the solubility product constant. So we need to find barium sulfate. And there it is right there, barium sulfate. And it is made up of a concentration of barium ions and sulfate ions, and the KSP value is 1.1 times 10 to the minus 10. Okay, we'll write that down right here. So the KSP for barium sulfate, 1.1 times 10 to the minus 10. Now, what is going on when barium sulfate is in water? Well, it's breaking down, it's dissolving. Barium sulfate is a solid, but it's going to break up into its component ions. Which ions? Barium and sulfate. So now we have an equation which represents the dissolution of barium sulfate. We also have the KSP value for barium sulfate, which is 1.1 times 10 to the minus 10, which is equal to the concentration of barium ions times the concentration of sulfate ions. Okay, let's continue. Let's determine the concentration of these ions. First, we'll start with barium right here. The moles of barium are equal to the volume of barium, 0.020 liters, times its concentration, which we were given. And that comes out to 0.00020 moles of barium. Easy. We've got moles of barium. Now let's find the moles of sulfate. Moles of sulfate equals the volume, 0.020 liters, times the concentration of sulfate, which was 0.0050 molar solution that we've got here. So now we're going to come up with 0.00010 moles of sulfate. So we know the number of moles of barium and the number of moles of sulfate. Next, let's take a look at the total volume. What is it? Well, we get our total volume by adding up 0.020 liters plus 0.020 liters, and we get a total volume of 0.040 liters. All right, we have volume and we have moles. What do we find next? Molarity. You got it. Let's find the molarity. The molarity of the barium ions equals the number of moles divided by the volume. And we know those values. We just found them out. Now let's plug them into the equation, do the calculation, and we get that the molarity of barium ions is equal to 5.0 times 10 to the minus 3 moles per liter. Now, we also need to get the molarity of sulfate ions, and that's equal to the moles of sulfate divided by the volume that they're in. And that comes out to 2.5 times 10 to the minus 3 moles per liter of sulfate. Next, we've got to multiply these concentrations, one times the other. Remember, molarity was equal to concentration, so we are golden. We are right in the place that we need to be. Let's see what happens next. Okay, We have a concentration of the ion product equals the concentration of barium times that of sulfate. We just found those values. Let's plug them in. So we're going to plug in 5.0 times 10 to the minus 3 and 2.5 times 10 to the minus 3. If we do the math, we come up with an answer of 1.2 times 10 to the minus 5th. That is our calculated concentration of ions. But remember, before we looked up on that chart, what was the KSP for barium sulfate? And we found that to be 1.1 times 10 to the minus 10th. Now, the value that we found was greater than the value that was listed on the chart. Therefore, a precipitate forms. And that's how you do this problem.